Good morning, everyone. Welcome to this session where you'll learn how to perform the first experiment in Digital System Design Lab. This experiment is all about verifying the logic gate ICs. The main objective here is to verify the functionality of logic gate ICs by applying inputs and observing the output. The logic gates are basically classified to belong to three categories: basic gates, universal gates, and advanced gates. Under basic gates, you have AND, OR, and NOT gates. Universal gates are NAND and NOR gates, and advanced gates are XOR and XNOR gates. So before going to perform this particular experiment, I would like you to learn some basic performance parameters related to ICs like rise time, fall time, fan in, fan out, propagation delay of a gate. So these are all terms which have certain meanings with respect to the performance. So I want you to learn this particular terminology before going to perform experiments on digital ICs. And along with that, I have also given here certain reference points which will help you to perform your experiment in a better manner. And these are the symbols and truth tables of the logic gates which you are going to implement. The apparatus required for this experiment are: you need all the digital ICs of various logic gates, which we are going to verify the functionality, and you need power supply, a breadboard where all the entire circuit is put together, and connecting wires to connect all the components. So the observations from the procedure to make the connections are given here. Please follow this particular procedure, then you will be able to perform your experiment with minimum glitches. The only important point is avoid any loose contacts while making the connections. So once procedure is done, then what kind of observation should you do? The observation is you need to verify the truth tables of logic gates, which I am again providing here for your reference. So here A and B will be the inputs of any logic gate. So you can see in the truth table the inputs are A and B. They can be either 0 or 1, and this is your output. So for different combinations of your input, are you getting that particular output or not? This is what you need to observe from this particular experiment. So here I have given you an experimental setup. So your circuit looks something like this when you connect it in TInkercad software. So it's not needed that you place the components in the same positions what I have shown here. You can place it anywhere you like. I have only given the circuit for your reference. So in this circuit, you can see that there is a switch here through which I am going to apply the inputs A and B. There are 4 switches here, out of which I am using only the first 2, 1 and 2 as my A and B inputs. Then I have an LED here through which I am going to check the output of that particular gate. And this IC is the AND gate IC. So basically I am trying to verify the functionality of an AND gate. Okay, so this is the setup here for your reference. And now let us learn how to simulate the circuit by developing it. We have already developed the circuit in TInkercad. Let us see how to simulate that particular circuit. Now here you can observe the circuit here. Now once this setup is already shown to you, now what you have to do is apply your inputs and observe the output on the LED. There is a start simulation button here. Click on that. So now the voltage is being applied to the circuit. Then through these switches, apply that input to the IC. So now, since both the switches are in off position, that means I am applying logic 0. So my LED is also 0. But according to AND gate truth table, this LED should glow when I am applying both the inputs as 1. So now you can see the LED is glowing. Now again, let us make one of the inputs 0. You can observe that the LED is switched off again. Again, if you make it 1, then again it is on. So this is how you can simulate the circuit. So once you are done with that, then you need to still perform the remaining part of the experiment. So what we have done is we have verified the truth table of AND gate IC. But along with that, you should also verify the truth tables of OR gate, NOT gate, NAND, NOR, and XOR. So basically what you need to do is, in place of this particular IC, AND gate IC, you can place other gate ICs and verify their functionality according to their truth tables. Okay. So here I have provided you with some Viva questions which will be helpful for the Viva of this lab and also for your placement interview purposes. Thank you. Hope this session is useful to perform the experiment.